Hi, my name is Catherine Martin, and today I'll be presenting my project, Visualizing Telematic Music Performance, specifically my contributions as a part of the robotics subteam. So this is the MDP project, a part of FEAST, which is the Faculty Engineering and Arts student teams. So my faculty advisors were Professor Gervish, Professor Granzo, and Professor Albert, and my honors advisor was Professor Gervish. So to understand the motivations behind this project, it's essential to understand what telematic music is. So telematic music is music performed live and simultaneously across disparate geographic location, facilitated by bidirectional audio and sometimes video transmission over the internet. There are a lot of challenges with telematic music, including delay in video transmission, limitations in capturing visual cues, and the fact that video transmission is only two-dimensional. So research has really shown that three-dimensional movement is a lot more effective and expressionful than just two-dimensional. And here on the right, you can see an image of two people playing a duet live face-to-face, and then on the bottom is someone playing a duet using video transmission. So the project goal is to create a mechatronic display that captures the actions and gestures of the musician while also communicating the ambiance of the music to an audience. Some key objectives is to be able to communicate important cues, be expressive, and not have an anthropomorphic robot. So we don't want something to be an exact representation of a human because it might not be necessary. When musicians play and signal one another, it is really just a specific signal, and just having the entire human representation just might be more distracting than helpful. So on the right is actually a mechanical sculpture by Jennifer Townley, and this is just a really great example of something that's very expressive and non-human-like, and kind of looking at kinetic sculptures like this really helped kind of inspire a team to kind of go in the right direction of what we wanted to maybe more long-term. So before we kind of go more in depth of what the robotics team did, it's important to really touch on what the motion captured mocap team did. So one of the biggest contributions was creating a 2D abstract visualization. One of the most influential ones they created was called a bounding box. This is a visualization that placed 3 data points in space and enclosed a box around that. They're also able to kind of add this additional feature that would rotate the box and create more of a cube visualization, as you can see at the bottom. Another really important part the mocap team helped with was collecting and filtering data collected from the motion capturing suit, which you can see from the right. So the way the robotics team kind of approached this problem is that we did a lot of brainstorming and rapid prototyping. So one of our prototypes was called the Dowel Arm. This was inspired by a violinist's arm, and we used it required 2 motors, but one downside to this design was it only had 2-dimensional movement. But we really wanted to have that 3rd dimension because as a part of our project objective, we wanted to create this 3D mechatronic system. And then also what we had seen from the mocap visualizations was just even adding that 3rd dimension for a video transmission. It was very impactful and added a lot more to the data. So for the next iteration, we have something now called Box on a Stick. This is just the next iteration of the Dowel Arm. It has 3 motors, which means it has 3 dimensions. So as you can see on the right, we have the arm subsystem, which is seen in the green and blue, and then that attaches to the base, which was made out of aluminum strut via the motor mount, which was made out of aluminum. And the arms themselves were made out of plywood. So here's a GIF of the mechatronic system moving. It's a lot more expressive and than the Dowel Arm, and also has unintentional movement as well. As you can see, since that entire subsystem is near the top, created a lot of torque kind of rattling the base. Some of the unintentional movement isn't entirely bad because we don't really want to have a very rigid system, but there is to a point where it could be distracting as well to the audience. So one thing I think is really important to note is that there is not a direct relation to the musician's arm when they are playing the violin. So that means that there's this learning curve for the musicians who are playing alongside this mechatronic system. So here's a video from our workshop. So this is a Sonata of Two Violins by Sergei Prokofiev, and this is the second movement of that piece. And in this video, Yuki, the violinist, is playing alongside Professor Albert, who is in another room, and his motions are being captured for this by the mechatronic system. So one thing we kind of did during this workshop, our main focus was trying to get some feedback and just the general impression of the work we've done so far. This is really not a final product, so we didn't want to have a quantitative survey since we were just not quite ready for that, and any results from that might not be entirely accurate. So we had this optional Google qualitative survey that had 3 questions. The first question was, considering the entire workshop, what did you observe that seemed particularly effective? And then again, considering the entire workshop, what did you observe that suggested opportunities for greater exploration? And was there anything particularly surprising about the presentation in ways that either exceeded or fell short of your expectations? So there were nearly 20 non-team members in the audience. However, only 3 actually responded to our survey. So even though we had a really small level of response, their feedback was still very helpful. And I think more importantly was that we had a lot of discussions and questions between performances during our workshop that really, I'd say, fostered that discussion of what our design intents were, explaining how some of the mechanism worked, and also discussing a little bit of what our next steps could be. Because I think one of the best ways to really describe this project is that this project has really just begun. This is not a final design at all, but I really do think it's a step in the right direction. We really want to incorporate the feedback from the workshop. Some of their feedback really focused, I'd say, on maybe just kind of how we structure the workshop and to structure in a way that kind of explained a little bit more of what our intent was before we just entirely showed the piece, and then also some future steps that we could explore as well. Kind of going into that, some of those next steps would be to like iterate upon this design, lessen some of that rattling. One person noted that they found the rattling of the bass a little distracting. Figure out a way to communicate more of the smaller motions. That was another discussion that was brought up during the results. Wondering how we'd be able to motion capture instruments that had less large movements than bowed instruments do. Another point that was brought up during the survey was capturing data in different ways rather than just motion capture if you had like a breath sensor or some way to capture eye contact. So some longer term goals is we could create a mechatronic system that is more responsive, really shows when both the musicians are acknowledging it. We could explore a non-box-like shape, and then also create a mechatronic that is more universal for other instruments as well. So I just really kind of wanted to say, acknowledge some of the students that I was working on with this team. There was about 9 of us, and really could not have been done without them. Also, faculty advisors were always very helpful and really kind of pushed us and challenged us to figure this out. And also thank you to my Professor Gillespie and John Ward, a technician at the robotics building that really helped. And this project was made possible by a grant from the Arts Initiative at the University of Michigan and with support from the Arts Engine and Feast program. So kind of just, I guess, reflecting more about this presentation in general, I really enjoyed my time working on it. I chose this project because I wanted to be on a team and focus on a topic that wasn't just engineering, which I felt like I've been doing my whole kind of career at college, and I've always liked music. I was involved in music when I was in high school, so that kind of drew me into this subject matter. And that being said, I think I learned a lot, especially since there were no quantitative engineering I'd say like specifications. That kind of added, I'd say, a challenge. I was not really used to that. Usually a lot of projects I've been on had really clear defined objectives of what they wanted from us, and this project did not. But with that being said, I think that that's actually kind of normal for a lot of projects in the future, especially ones that have a little bit more creative space and a little bit more artistic. So even though it was kind of challenging, I really enjoyed it, and I feel like I learned a lot from it. So thank you, and please let me know if you have any questions.